Lesson 8:15, Classifying Triangles. A triangle, of course, in a very general sense, is a three-sided polygon. It's clearly two-dimensional or flat in nature. It's made up of line segments and there's no gaps. Now, when you are talking about classifying triangles, classifying something is another word for sorting it or grouping it based on characteristics. Take a group of students. We could sort those students, boy, girl. We could sort students shorter or taller. We could sort students by, are you wearing shoes or sandals? Are you wearing a hooded sweatshirt or not? We could sort students by the color of their hair. We could sort students by, are you wearing eyeglasses? And a number of other characteristics. Take your pick. When you talk about classifying triangles, there are, in general, two, I'll call it, sorting groups that we deal with. First, we can talk about the characteristics of the sides of a triangle, and then characteristics of the angles of a triangle, sides and angles. Now, within sides, you've got a scalene triangle. Does it have three sides? Yeah. Are any of the sides equal? No. No equal sides. And I'd encourage you to copy these down onto your page. I probably should have used the white space over here to give myself a little bit more room, but that's okay. The next term is isosceles. And spelling this is sometimes a challenge. An isosceles triangle, does it have three sides? Of course. All triangles do. And clearly I did not spell this right. I just made the comment that spelling it is a challenge, and there you go. I wasn't kidding. Spelling it is a challenge even for your teacher. Isosceles. An isosceles triangle is one where you have two of the three equal sides are equal, two equal sides. And then, of course, last but not least, you have an equilateral triangle where, you guessed it, all three sides are equal. And equilateral, you kind of hear the word equal in there in a way, so that's one sort of tip for remembering that, three equal sides. So there you have it, your three terms when you are classifying triangles by their sides. A scalene triangle has no equal sides. Isosceles triangle, two equal sides, and equilateral triangle has three equal sides. Moving on to angles, and actually I am gonna be reasonable here and just give myself some space. First, we have a right triangle. A right triangle is one that has, you guessed it, a right angle, a perfect 90-degree square corner. It has a right angle. Then you have an acute triangle. Oh, he's so cute. You can just imagine Grandma Triangle squeezing or pinching the cheeks of little grandchild Triangle. Oh, my little pumpkin, my little triangle, he's so cute. An acute triangle has acute angles, has all acute angles. All three angles are less than 90 degrees. And then finally, you've got your obtuse, the big fella. An obtuse triangle has, yep, it's got one angle that's greater than 90 degrees. Has an obtuse angle. Okay. And let's apply this knowledge here. Number one, circle all the names that describe the shape. Well, first let's look at this triangle from the perspective of its sides. Are all three sides the same? I don't think so. Close, but I don't think it does not look like an equilateral. Are two of the sides exactly the same? Close, but I don't think so. I think it's, if you just look at the sides, I'm thinking it's scalene. The sides are close, but not equal. Now let's look at the angles. Does it have a right angle? Nope. Does it have all acute angles? Less than 90, less than 90, less than 90? Yes. Oh, he's so acute. And it can only be one of these and one of these. So we can eliminate obtuse, but let's just double check. Is there an obtuse angle in here? No, there's not. Moving on to number two, sides first. This little mark tells us that these two sides actually are the same length. The diagonal is going to be a little bit longer. And so the fact that two of its three sides are the same length makes it an isosceles triangle. And looking at the angles, you can see right there, this symbol tells us, ding, 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 we have a right angle, and therefore this could be considered a right triangle. Number three, first look at the sides. Any equal sides? No. I think it's a scalene. How about the angles? Any right angles? No. Are they all acute? These two are acute, but this big fella, take a look at it, greater than 90 degrees. This is obtuse. That makes this an obtuse triangle. And finally, number four, looking at its sides. To me, three sides look the same. Equilateral, three equal sides. Looking at the angles, all acute. Moving on to the sketching at the bottom. And the task is to sketch a shape that fits the description, if possible, an obtuse equilateral triangle. Is that going to be possible? No. Look at triangle 3 above. That was the one from the samples given that was obtuse. In order to have this angle, this greater than 90-degree angle, you need this kind of larger, more spread out opening. And I think that alone makes it impossible to draw a shape where all three sides are the same, where all three sides are equal. Number 6, a right obtuse triangle. Well, there's a right angle, and no matter how far I stretch this thing, imagine I could make this short, I could stretch this out and make it long. These two angles are not going to be greater than 90 degrees. In fact, if you add up the three angles in any triangle, you're going to get 180. So if one of those three angles is 90, then by definition, the other two angles have to add up to be 90. So this is also a trick question. This is not possible. How about a right equilateral triangle? Again, let's start here. Yeah, I could imagine how these two sides are the same. But to get that third side to be the same, there's no way I can do it. No matter how long or how short I go, it's just not going to be possible. And finally, number 8, a right triangle with a line of symmetry. Yes, thank you. This I think we can do. This I think we can do. Okay. Neatness, 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 neatness. Symmetry, 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 symmetry. And there you have it. It looks similar to some of those paper footballs that some of the kids in our class have become good at making.